About the welding testing, that is the last part of that unit under unit 3, and end of this lecture student will able to learn about the testing, that is the destructive and non-destructive test of that weld joints. Weld inspection and testing. What is the weld testing? So methods of weld testing and analysis to is used to assure the quality and correctness of the weld after completion. Means after welding, that weld strength and weld quality is good or bad, means poor. So using weld testing we have decided. So this term generally refers to testing and analysis focused on the quality and strength of the weld. Means after testing we have decided that weld is good or bad. Okay, means quality of the weld and strength we have decided by the weld testing. So why to test the weld? Okay, to ensure the development of the weld by collecting qualitative data and quantitative data. Using that data we have decided the weld quality is good or bad, and also strength of the weld is good or bad. By using weld testing we have decided. So to get the assurance of the weld strength and good quality weld, so to get that things we have collected some qualitative data and quantitative data. Qualitative means that comes under non-destructive test. Okay, and quantitative data that decided hardness, tensile strength, ductility, toughness, fracture toughness. So that type of magnitude we have collected from the welding surface, and to assess suitability of the welding for specific applications. So we have collected that qualitative and quantitative data from the welding zone, and by getting that data, after that we have decided that weld quality is good or bad. Now how to test the weld? First one, stages of inspection. Okay, means stages of inspection means before welding, during welding, after welding. Okay, so in that cases we doing the some inspections. Okay, and testing, what is the testing procedure? Two types of testing procedure is there. One is destructive, another is non-destructive. Using that procedure we have decided about the weld quality and weld strength. Before welding we are performed some operations. Okay, what are the operations? We remove the surface oxide grease with weld removes, and also some other impurities also removed before welding, means cleaning is required before welding. Okay, then another edge preparation, means dimension and quality of that particular edge of that particular plate, or where we want to perform the welding. So in that area we take the edge preparation process. Another, backing of electrodes etc., means removal of the moisture from electrode coating. Means when we use the welding torch, sometimes welding torch we have coated, so from that particular area we remove the moisture. That is very important. That are the some welding cleaning process. Means we use some acetones, also we are using some other liquids or other solid material, something we have used for clean the metal surfaces before the welding. So after welding, after performance of the welding, so what happens? Removal of the of the slag means some extra material, some extra flux material will be accumulated to the weld zone, means some extra flux material or slag material will be accumulated to the welding surfaces. Okay, and so for removal of the plug, removal of the slag, we use the spinning process, means stress removal, means that type of chipping hammer we have used. Okay, what are the components? So what are the denotions to that particular welding hammer? Means that part is the ball pin. Okay, that is the cheek part, and that is the roll part, and that is the striking face, and that part is the neck face. That part is the neck face, and that is the handle. Using that chipping hammer, we remove the extra slack portion from the welding zone. Post welding treatment, sometimes refinement of the grain structure and stress removal, that is also required, means that is called post welding treatment. Weld testing, first one, destructive type testings. So in that cases, physical damage to the workpiece and weld joint, means to get the quantity data from that destructive testing, we collected some data, means what is the tensile strength, what is the toughness strength, so toughness, ductility, so that type of data we have collected from the destructive test. Okay, means due to destructive testing, we damage the weld joint, and also we damage the workpiece also, means quantitative data obtained by the destructive testing. And in case of non-destructive testing, without physical damage of the workpiece and weld joint, we have collected the data, means here we are getting the qualitative data is obtained in case of non-destructive testing. Now destructive type weld testing, here we some part, means we damage the workpieces and also damage the weld joints, and by damaging or by broken of the welding joints and workpieces, we have get the some quantitative data, and based on that we have decided the weld surface is good or bad, or strength of the weld is good or bad. Using that data, we can taking the information from that destructive weld testing. Now that can be divided, that destructive weld testing can be divided into two parts. Some test capable are being performed in workshop, and some weld testing has been performed in laboratory test. Okay, that is the microscopic and macroscopic chemical and corrosive performance. Okay, means sometimes some getting particular some precision data we have used laboratory, and some tests are performed in also workshop, and based on that quantitative data we have decided about the quality of the weld. Reasons. What are the reasons? Defects occur during welding which affect the quality and hardness of the plates. Means already I have discussed about the different welding defects. Due to that defect, sometime weld quality will be deteriorated. So before using that welding plate or welding some components, so before using, we must be checking the quality of the weld strength. So that is necessary. Otherwise, we are not checking. We directly send to the some market for use purpose. So sometimes if weld quality is very bad, so the lifetime, means life period of that welding joint will be deteriorated. Means after use of sometimes that will be destructed. So before using any weld joint components, so must be testing is required. Other defect occurs through the lack of knowledge of skill of the welder. Means for welding, any type of welding, skill operator is required. Means anyone does not do the weld. So for better welding, always skill operator is needed. Another, for training of the welders. So sometimes if we are using some persons or using some robots for welding purpose, you must be trained them. Otherwise, he will not do the proper welding. What are the types of the destructive testing? Tensile test and bend test, that has been done in workshop. And hardness test, toughness test and fatigue behavior, that test has been done in laboratory. First, tensile strength. For getting the magnitude of the tensile strength, we use sometimes universal testing machines. Using that thing, sometimes using that machine, we have get the tensile strength magnitude. Means tensile test means used to check how the weld joint will perform under tensile loading. Means that is the component. That is the component. Here we apply the force. In that side also we apply the force. After a certain time, here neck type shape will be neck type same will be formed, and after certain time that will be cracked. Means before cracking we have collected some tensile strength data. Modulus of elasticity, yield strength, ultimate strength, that type of data we have collected during deformation of that particular weld joint. That is the tensile testing most simple and common method. Using universal testing machine, we collected that tensile strength data easily. And also we have decided modulus of elasticity data, yield strength data, ultimate strength data, that type of data we have collected using that machines. Means using that machines means here tensile strength test specimen of the test method means that is the weld specimen, okay. That in one side one specimen, one end of the specimen will already we have fixed, and at other end we have fixed of that particular specimen. Then we apply the tensile load. We have pressure the tensile load, and due to that thing, after certain time that will be start the cracking. Cracking means deformation will be started, and at that time we have collected the tensile strength data, yield strength data, and also modulus of elasticity data. Means when it will start the cracking, means at that time we have collected the tensile strength data. Means up to that strength that weld joint can sustain. Beyond that, the weld joint will be cracked. So means we are getting some endurance limit to that welding joint. That is the main thing of that testing procedure, tensile testing procedure. Means here tensile strength we can decide it using tensile load and area. Here area means W into T, width and thickness of that particular plate. That is the tensile test specimen. And here tensile test result must be supported by stress strain diagram. Sometimes means universal testing machines we have get some stress strain diagram. Based on that we have decided the data, tensile strength data and modulus of elasticity data. So different specimen, different stress strain diagram has been acquired. So here we are taking some informations, means different welding process are there. Here one is first one base metal. If we are doing the tensile testing, the base metal stress strain diagram has been that type. Means what happens? Means here stress has been increased and very less amount of strain has been changes. Means after certain time stress will be increases. Okay, means here up to that point the stress is maximum and also strain also increases. After optimum limit it will be again the stress will be decreases because the material start the yield formation and after certain time it will be destroyed. Means the strain rate also decreases. That is the base metal. Another is the submerged arc welding. Means that line shows the submerged arc welding stress strain diagram. Okay. Another is the submerged arc welding. So in that cases we have seen that that is the stress strain diagram. Another is flux core arc welding, means FCAW. That line shows the flux core arc welding line, means stress strain diagram. Another is the AGTAW, argon gas tungsten arc welding. So in that cases means that is the AGTAW, means different weld welding joints mean welding techniques has different stress strain diagram. Here also we are seeing that is the stress MPa and that is the strain percentage. Here we are seeing that is the specimen 01, specimen 0, specimen 1. In that cases that line shows the stress strain diagram. Another specimen 14 means that line, specimen 14 means that lines. Another specimen 15 means that is the specimen 15. Specimen 16 means that line. And base metal means this line. Means every specimen has different stress strain diagram, and on that basis we have collected some data, tensile strength data, yield strength data, and also we have collected some modulus of elasticity data. Based on that we have decided the quality of the weld. Bend test also is one of the most important commonly used destructive test to determine the ductility, soundness of the weld joints in terms of porosity, inclusion, penetration and other macro size weld discontinuities. So based on that bending test we have collected that data, and after collecting that data we conclude that up to that data the weld quality is good, and beyond that the weld quality will be deteriorated. The outside bend is extensively plastically deformed, so that any defects in or embezzlement of that material will be revealed by the premature failure of the coupon. Means we have collected that data before failure, and then we can tell that up to that data that weld joint can sustain, and that up to that data the weld joint also very good. How to bend that one welding joint surfaces? First, bending of the weld joint can be done from face or root side depending upon the purpose. Means here we want to bend that across that surfaces, bend to across that surfaces. Okay, that is the former, and that is the some support, and using that support we perform the bending operation across that welding joint. Second one, whether face or root side is assessed. So across the root side or face side of the welding joint we want to bend that, and based on that basis we have collected the data. ASTM means American Society of Testing Materials. Sometimes they use some particular specific specimen, and based on that they have decided using that data, up to that data the weld quality is very good. And guided bend test for ductility of the welds means using that things the bending test collected the data, and based on that we have decided the bend weld strength is good or bad, decided based on that particular data. Hardness test that has been done in the laboratory. So here we are seeing that is hardness means it is the resistance to indentation on penetration. Means when we create the pressure on that particular specimen, so it will resist. Okay, sometimes for deciding or for determination of the hardness we use the harder material, means very harder material than the workpiece, and based on that we have decided the hardness in the hardness testing machine in our laboratory, usually refer as a measure of resistance to abrasion or scratch formation. Due to application of heat in welding, materials like hard enable steels, cast iron, they are subjected to more hardening takes place in that particular metal zone. Sometimes also more harder material also take in case of aluminium also. So due to that thing we have decided the magnitude of the hardness. Means some Rockwell scale is there, Binel scale is there. Using that scale or using some other testing procedure, we find out what is the hardness of that particular weld joint. Means if some scratch or some penetration, means some indentation will be formed when we apply the pressure on that particular joint. Some pressure, we apply the pressure or load will be applied, and due to application of the load, that type of depth will be generated, and based on that we have collected the data, hardness data. Okay, means up to that data the weld quality is good, otherwise the weld quality will be deteriorated. Hardening, softening phenomenon, that also depends upon the head zone. Means if heat affected zone occur to that particular welding joint, some quality of the weld surface may be deteriorated. So always we taken care about the head zone, means heat affected zone. Okay, before taking the hardness value, always we are taken care about the head zone. That is, that zone sometimes deteriorates the quality of the weld surfaces also. Toughness test. What is the toughness? Toughness means the shock absorption capacity is called toughness. So toughness is the ability of the material to resist both fracture and deformations. So based on that, the toughness test stimulates the service condition of a compound encountered by the components. So that things we have applied, that toughness thing or matter we have used in transportation, agriculture and construction equipment. That thing is very essential in case of toughness data. Okay. So that can be determined by the calculating energy absorbed by the metal before fracture. Before fracture, we have calculating the energy. Means we have decided up to that energy is suitable in case of that particular weld joint. Means up to that energy that can absorb. Means up to that energy that weld joint also sustain. So based on that data we have decided. Some graphs, test and graph here, if we are using high carbon steel, that is the strongest material. So here the change of stress strain diagram means stress near about constantly increasing and very less amount strain also changes. That is the toughest materials also, medium carbon steel. Means here stress also increases, strains also increases. Here very less amount of strain increases, but steadily the stress increases. In case of low carbon steel, that is the most ductile material, means here stress also increases, strains also increases, but after certain time the stress also deteriorates. Means stress curve will be decreases, but stay. We use the Charpy impact test and I-joint impact test. In case of I-joint impact test, held vertically, means the sample is kept vertically, okay, on anvil as cantilever. Cantilever means one end fixed, other end free, and cantilever type and notch faces on that pendulum, means one notch faces we have created to that particular sample. In case of Charpy test, here sample has been kept horizontally on anvil as simple supported beam, means here sample has been kept simply on the particular support. On that particular support we kept the sample, means as a simply supported beam. In case of simply supported type, notch is opposite side of the pendulum impact, means just notch each opposite side of the pendulum, that will be simply supported type. In that cases we have kept the sample. Charpy impact test, here we are seeing that Charpy V-notch impact test is the most common fracture toughness test used in industry, and using that test we have decided about the toughness. Using that test we have decided the toughness data. A notch type specimen we have used, and that notch type specimen is broken by the swing pendulum, and the amount of energy required to break the specimen is recorded in foot-pounds or joules. Means some particular dial gauge is there. When the swing, that pendulum is broken, that sample, so in that time we are taken some particular data, and based on data we collect, we have determined or we have calculated the energy absorbed data. So this is determined by the how far pendulum swing upwards after it fracture the specimen. means that swing means if we are showing the picture, so that is the hammer type chीज, means hammer, that is the hammer, means here specimen is kept in that particular places, means using when hammer will be means open, that will come out and on that particular specimen strike on that particular specimen and specimen will be broken, and at that time we are taken some particular data in that particular scale we are collecting some data, and based on data we are calculating the absorbed energy. That are the specimens. That type of V notch will be created. And across this V notch we strike by that particular hammer, and that is the some cross sectional area of that particular specimen. That is the near about square type cross sectional area that side. Okay, means that is the 10 millimeter and that is the 10 millimeter, and that is the V notch we have created. That is the V notch, and the angle near about 45 degree. So from that particular testing, we have decided that test has been done low temperature, the material is more brittle, impact toughness is low. But in case of higher temperature, material is more ductile and impact toughness will be higher. Now, so at that cases we are seeing that the fracture energy joule and that is the temperature. So in that cases we are seeing that the parent metal, that is the parent metal, that symbol shows the parent metal, means here fracture energy will be increases with increasing temperature. Okay, but in case of weld electrode, weld zone means that is that line, that is the weld electrode zone, means here change in temperature is higher, but fracture energy change in fracture energy is less amount, means it will also increase it, but very less amount of fracture energy will be increased in that particular cases. I-joint impact test. Here we are seeing that the specimen at room temperature, that test has been done at room temperature, and here also in that time the machine allow the temperature to increase, maybe temperature maybe increases or decreases at room temperature. Introduced a significant error when conducting test at various temperatures, maybe the linear expansion of that particular material may be affected by the temperature increasing and decreasing. So that test may be affected by the various temperatures. And in that cases, impact testing machines, that is the pendulum, that is called pendulum, and that is the energy readout scale, and here specimen is kept vertically. And that also hold properly also, and that is the pendulum control levers, and when open that levers the pendulum come and also strike on that particular specimen, and due to striking of that pendulum that specimen also broken, and in that time we take out the energy. We are taking the data from that particular scale, energy data we have taken from that particular scale. So that are the specimen, that is the cross sectional, means that is the square type specimen, means across the width section, that is the square type section, and here also we have seen that is the V notch, and the angle is 45 degree. Okay, and that V notch has been taken from that side, that is the length is 28 maybe millimeter or maybe centimeter, or here we are taken the length from 47, that is maybe 47 millimeter, maybe 47 centimeter, means that V notch taken from that side, the length is less and that length is higher, and that side we are hold in that particular holding place. Okay, and that is the broken specimen, by the impact testing machine. Fatigue test means ASTM E4 standard specimen we have used for fatigue test, means fatigue means when repeated cycle of load we have applied, means repeated type of loads we have applied on that material, the tolerance limit, endurance limit of that material will be deteriorated. Means continuously we are striking on that particular materials. So due to continuous striking or continuous applying force, the material strength will be deteriorated. Means after certain time the material will be failure. Means fatigue, means that material going to that will be going to destroy it. So in that cases we are taking the data, means for fatigue test we are taken one standard specimen, means American Society Testing Materials E466, that standard specimen we are taken for fatigue test. Okay, fatigue performance of a component can be determined by the endurance limit, means up to that limit the material can sustain. Means we are doing the welding to that particular specimen, and using that component, means weld component, using that component we are doing the fatigue test. Okay, and using that fatigue test we have decided the endurance limit, means up to that limit the weld can sustain. After that the weld strength will be destroyed. Another number of load cycle that joint can be withstand, means continuously we apply the load on that particular specimen. Due to continuous application of the load, the material will be failure. Okay, means here we calculated in that test endurance limit. Another is number of load cycle that joint can withstand, means joint can sustain. A fatigue test specimen, that type of specimen we are taking. What type of loading we are taken? Means type of loading is axial pulsating, reverse bending or tension compression. So that type of loading we are taken. What is called stress ratio? Minimum stress to maximum ratio. And also sometimes also affect that test temperature and environment, mean ambient, vacuum, corrosive type of sample. Based on that we are perform the fatigue test. What are the first steps to conduct the tensile test for assessing the yield strength of that particular specimen? First test is conduct the tensile test to get the yield strength, means up to which data or up to which particular reading the material will start the elongation, means material will start the deformation. Means at that time we are taking the yield strength data of that particular specimen. Then we plotting the stress to number of cycles curve, means that is called SN curve. And fatigue test is conducted with maximum applied tensile load corresponding to 0.9 times of yield strength to determine the number of load cycle required for fracture. Means here using that data we plot the SN curve, and from that SN curve we have determined the yield strength, and also we are determined some other data also from that particular curve, from that particular fatigue test. Sometimes add in the same way the test repeated for the some data, continuous data we are taken, some standard data 0.85, 0.8, 0.75, 0.7, etc. That type of data we are taken for plotting the SN curve, and from that SN curve we are decided some particular endurance limit data, and also load repetition of the load of the means number of the load of the cycle that joint can sustain, means that data we have decided. Now we are coming up to that thing we have described. I have described about the destructive testing. Now I will describe the non-destructive testing methods. And in that non-destructive testing methods, no damage to be held to the welding joint. Okay, by using some non-destructive testing, we have collected some qualitative data. Based on that, we have decided that weld joint will be good or bad. And white group of analysis is there, techniques used in science and technology industry to evaluate the properties of the material component without causing damage. Means no damage has been occurred to that welded joint, and on that basis we have collected some qualitative data. What are the some uses of NDE methods? First one, flaw detection and evaluation method, leak detection method, location determination method, dimensional measurements, another structure and microstructure characterization, estimation of the mechanical physical properties, states and dynamic response measurement, material sorting and chemical composition determinant. But based on that, we have decided that weld joint is good or bad. Means that is the non-destructive testing methods. Means here no damage takes place to that particular welding joints. Why non-destructive? Means test pieces to be precious to be destroyed. Means all the welding joints, all the test pieces are precious. Okay. If we are decided that a weld joint, what is the quality of the weld joint using non-destructive testing, so that is very good. Means we do not destroy the welding joints. Okay. Test pieces should be reused after inspection. Again, if we do not damage the test pieces, so again it will be reused. It is possible. Another, test pieces is in service for quality control purpose. For that things we are using non-destructive method. What are the major types of non-destructive method? First one, visual, magnetic particle inspection method, fluorescent dye penetration inspection, detection of the internal flow. For detection of the internal flow, we have used radiography, ultrasonic testing, AD current testing. That methods we have used. In case of visual inspection, most base and common inspection method tools include fiber scope, borescopes, magnifying glasses and mirrors. Some portable video inspection unit with zoom inspection of large tanks. Means here fiber scopes, borescope, magnifying glasses and mirrors, that type of things also we have used for visual inspection purpose. In case of portable video inspection unit with zoom allow, sometimes that things also we have used for inspection of the welding joint in case of large tank, vessels, railroad tank, cars and also sewer lines. So in that cases we have used the portable video. Sometimes robotic crawlers permit also observation in hazards on tight areas such as air duct, reactors, pipelines. In that cases we are using some robotic crawlers. So different inspection devices are there, and using that inspection devices we are use the visual inspection method. Means on that basis the weld joints is good or bad. Dye penetration method. Okay, so in that method, that is the widely used in case of non-destructive evaluation methods. In that cases, what happens? Now we first clean the weld joints properly. Okay, and inspect almost any material provided the surface is not extremely rough or porous. Materials that are commonly inspected using LPI include metals, aluminum, copper, steel, titanium, glass, many ceramic materials, rubber and plastic. In that cases, we are use the dye penetration method. So what is the method? In that method, what the method? In that method, we are taking the specimen. And before dye penetration inspection method, first we clean the materials, means clean the weld joints properly. After proper cleaning, then we put the dye. Okay, means after dye, then again we clean the surface, but in some particular defective area, but dye will be remain. In particular defective area, dye will be remain. So on that basis we can decide that particular area is the defective area in that weld joint, and after that we are taken initiative for remedies of that weld defects. Magnetic particle inspection method. Here what happens now, that is also non-destructive method. and fast and relatively easy to apply part surface preparation, not critical. As for some other NDT methods, MPI is one of the most widely used in case of non-destructive testing methods. MPI is the creates the magnetic fields, small magnetic particles such as iron filings to dictate the flaws in that components. Means here if we are using some magnetic particles or using some magnetic lines, magnetic fields, on that basis we have decided, means in that welding joints there are some cracks, some holes or some porosity will be present or not, okay, or some inside the weld joints also, that weld joints is good or bad, based on that also we have decided. Only requirement from an inspectability standpoint, that component being inspected must be made of a ferromagnetic, for in that magnetic particle inspection method the weld joint must be made of ferromagnetic material, means such as iron, nickel, cobalt. On that basis of the material we can do the welding, and after welding using that method, magnetic particle inspection method, we have decided that the weld joint is good or bad. And in that method we are do the welding in various manufacturing methods. In case of casting, forging and weldments, in that cases we produced different parts. Sometimes some parts we are welded in that cases also. Means particularly magnetic particle inspection method, particularly in that cases we manufacture the particles using ferromagnetic materials. If we do not use the ferromagnetic materials, we does not perform that inspection methods. That is not possible, because in that cases magnetic field lines or magnetic properties maintained in case of ferromagnetic materials. If we are using non-ferromagnetic materials, it is not suitable. So many industries magnetic particle inspection methods are used. Based on that we have decided that welding joints is good or bad, and strength of the welding joints are good or bad. Based on that inspection we have decided. Some examples we are taken, that using magnetic particle inspection method, that method will be used in case of structural steel applications, automatic application, petrochemical application, power generation. So many industries we have used that magnetic particle inspection method for inspection of the quality of the weld joints. In case of what are the basic principles, we have known that in that cases the some magnetic lines exit from some particular pole. Means here a pole where magnetic line of force exit, that magnet is called north pole, and where line of force enters the magnet, that is called south pole. Means here that magnetic lines, some magnetic lines exit and some magnetic lines are enter. So when we taken that process in the welding joints, when that magnetic lines will be passes, when some flaws, some defects are present in that weld joints, that magnetic lines will be deflected, and that can be shown some particular digital devices there, okay. And based on that digital device we have decided, means when magnetic lines will be deflected, so we can decided that in that particular places welding defects are there, and based on that then we have taken care about that defects also. Again we remove that welding joint, again we re-weld, okay. So based on that we have decided that that welding joint is not good, that good or bad we have decided, okay. That is the basic non-destructive testing method and very good method. Magnetic particle inspections means using that inspection method we are find out the cracks, voids, some porosity also present in that method, sometimes some blowholes, some incomplete fillings, that type of things are present in that particular weld methods, and using that method we have decided that problems or that defects to that particular weld joints. Here also some magnetic lines as example, means that type of crack will be formed in that particular weld joints. Okay, when that particular magnetic lines will be going from that side to, means from south side to north side, due to that presence of that cracking, that magnetic lines will be deflected. Means easily in digital device we have shown that that will be deflected. Means when that will be deflected, means we have decided in that particular places that welding defects are present. Means that type of welding defects are present in that particular welding joints. So based on that, we have taken care about that welding defects. Now, sometimes that type of shallow depth also created in that particular welding joints. Means that joints does not fill up properly by using the weld pool or weld bit. Means due to that thing, that problems has been occurred. And also that can be also we have carried out by the magnetic particle inspection method also. Okay, means number of problems or number of defects we have catched out by that particular magnetic particle inspection method. Okay, so based on that we have decided that method is very good method for inspection of the particular welding testing. Means that is the non-destructive method, because using that method we do not destroy that particular welding joint. Means again we reuse the welding joints. That is the best inspection method. Some radiography method also, that is also sometimes internal flaw or internal defects we have decided using the radiography method, and in that method some gamma or X-ray radiation we have used. Means sometimes some gamma ray we have passed through the particular welding joints. If we are taken that is some X-ray or radiation will be created. Means when we passes that particular X-ray radiation or gamma radiation through that particular welding joints, in that time we have shown that if any defects has been present to that particular welding joints, so what happens? Means that radiation may be deflected in that particular defects. That also we have shown in that particular digital device also. Means as like magnetic particle inspection method. Means when it will be deflected in that particular devices, we have shown that in that particular area that problem has been occurred. And based on that we have taken care about that defects. But that is also non-destructive method. Means here we do not destroy that particular work pieces. Means weld joint plates we do not destroy. So means again we will reuse that pieces also. That is the main basic things of that particular radiography methods. Ultrasonic testing, same thing. Ultrasonic testing, eddy current testing, radiography testing, magnetic particle inspection methods that are creates. Means in case of ultrasonic testing, here we created some high frequency sound wave are transmitted into material to detect the imperfections, to locate changes in material properties. Means any type of defects are present to that particular weld joints. When we supplying the high frequency sound wave, that type of we supply the high frequency sound wave, when we passes through that welding joints, that type of wave will be created. Means when any flaws or any problems has been present to that particular weld joint, that type of very long type wave will be generated. Okay, means that wave will be deflected. Otherwise in normal cases the wave will be as like we are considering as like straight line. Okay, but any flaws present in that particular welding joint, that type of very long type wave will be generated. And based on that we have decided that any problems or any defects has been present to that particular welding joints. That is the main thing in case of ultrasonic testing. Means the time interval between the transmission and reception of the pulses giving clues to the internal structure of that particular material. Means here we are taken some wave performance in that particular welding joints, and based on that wave nature we have decided. Means some problems has been present in that particular weld joints. Ultrasonic inspection methods means back surface, that is the crack echo, that is also crack echo, back surface echo. Means we are passing the ultrasonic wave, means here crack is there, means it will again retract it. Means if normal cases, we are taken that is the normal surface, so here that when ultrasonic wave is coming and it will start from that position, then again it will be retract. If we are considering that will take some maybe 1 second or some 100 microsecond, but in case of here we are taking, if that crack is there, but that take the less second, so less microsecond. So in that cases also we have decided that some problems or some defects has been present in that cases. Also based on the wave lines, we are decided some particular defects in that particular weld joint also. And eddy current testing, that in cases eddy current testing, that also created some alternative magnetic field. Means when because the flow of the circles and just below the surface of the material, interruption in the flow of the eddy currents caused by the imperfections. Means if any defects are present to that particular weld joints and we are passing the eddy currents, means some electromagnetic lines will be created, and when simply normal electromagnetic lines will be created to the proper welding joint, if any defectives has been present, that electromagnetic lines will be deflected, and due to based on the deflection of the electromagnetic lines, we decided, means in that cases the problems, any defects has been present in that particular weld joints. Okay, means that eddy current testing has been used any electrically conductive materials with reasonable smooth surface, and also test equipment consists of generator, a test coil and recording equipment, galvanometer. That type of instruments are required for eddy current testing, and that used for crack detection, material thickness measurement, sorting materials, coating thickness measurement and metal detection. In that cases we have used that eddy current testing methods. All these methods are non-destructive testing methods and very good methods. Without destroying the weld joint, we have tested the weld quality. And end of this lecture, students have learned about the destructive and non-destructive of that welds. And of that, the concluding learning outcomes of that unit 3, the student have learned about the introduction to welding process, classification of the welding process, type of the welding joint and their characteristics, and LO2 learning outcome 2, gas welding, different types of flames, oxyacetylene welding and cutting, and learning outcome 3, they have learned about arc welding, basic principles of the arc welding, voltage current characteristics of the power source problems, and voltage current characteristics, duty cycle, MMAW, manual metal arc welding, submerged arc welding, tungsten inert gas welding, metal inert gas welding. Another learning outcome 4, solid state welding process like friction welding, friction stir welding, forge welding, explosive welding, thermite welding, plasma arc welding, laser beam welding, electron beam welding, soldering, brazing, resistance welding and its types, heat affected zone. And learning outcome 5, they have learned about the welding defects, causes and remedies. And learning outcome 6, they have learned about the testing, weld quality testing, means that is the destructive testing method and non-destructive of the weld. Thank you.